Hello everyone. Now I'm going to explain the paper, which is Cockroach DB, a resilient geo-distributed SQL database, which is designed for modern global applications. Let's dive into the topic. Basically, this Cockroach DB is the application designed for more scalability, low latency, and fault tolerance. These are critical for maintaining high availability and user satisfaction. Especially in multi-region deployment. Like as the name indicates, it is geo distributed. It is the database is geographically distributed around the areas, like around the world. Additionally, regulating compliances such as GDPR, like general data protection regulations, like some areas like in Europe, they might have unique GDPR, and considering this requires specific handling for of data to ensure its security and locate specific storage. All these things are handled by Cockroach DB. Cockroach DB addresses these challenges with a unique design. Its fault tolerance, high availability, and enables consistent transaction across geographical distribution nodes. What are the key features? Main key features of Cockroach TV is like fault tolerance, geo-distributed partitioning, and replica placement, and high performance transaction. Let's dive into those topics. Um, fault tolerance. Fault tolerance by replicating data crosses at least three geographical zones, like the database, the architecture which uh, distributed replicas, at least three replicas across the geographical zones. Even if one fails, the system continues to function without any interruption, like without any down break. And also, automatic recovery mechanism ensures that the failed nodes are replicated, and also they are in proper synchronized seamlessly. Geographical distribution partitioning and replica placement. The database partitioning data based on geographical locations, ensuring that queries are served from the nearest node to minimize latencies. It also provides fine-grained control over where replicas are placed. High performance tolerance transactions. Uh, Cockroach DB employs a highly efficient transaction protocol that supports geo-distribution transactions across partitions while ensuring serialization isolation. Like it maintains like a high transaction, for all the for example, like if you are we are crediting amount from a user and it is debiting from account, for example, I'm saying like it will maintain all the ups and downs in the transaction history. And now coming to the architecture, it consists of SQL layers. The architecture consists of multiple layers, which are SQL layers, transaction, KV layers, distributed layer, replica layers, and storage layers. Um, SQL layers. This is a main interface used by the users to interact with the database by using the query phrasing, handled by query phrasing, optimizing, and schema management. It allows seamless database management schema changed without downtime. Coming to the transactional KV layer, ensures that transactions are consistent and isolated across multiple changes. It handles professionally changes until the commit is finalized. Uh, as I said the example before, it will until the commit is finalized, it will maintain the transaction upgoing. Distributed layer. Distributed layer into ranges. It distributes the data into ranges and routes queries to appropriate nodes for efficient processing. Replica layer is responsible for replicating the data across a node using raft consistence, ensuring durability and fault tolerance. And storage layer is responsible for storing the data, and here it is managed by using rocks db. Fault tolerance and high availability. In Cockroach DB uses the raft algorithm for replication. Each data partition has multiple replicas, which one act as a leader. The leader manages write operation, and if it fails, a raft elects a new leader automatically to maintain consistency. Automatic load balancing, which is nothing but when a node fails, Cockroach DB redistributes the data to healthy nodes, the nodes which are active. And this process includes creating new replicas for replicated ranges. And replica placement. You can manually control where replicas are placed, or let or an automatic replication is available in Cockroach DB. Like user can manually define like in which region the replicas has to be, and there is also automatic replication available in Cockroach DB to handle the automation chances fault domains like regions or other failures. To overcome that, it maintains automatic replica placements. Data placement policies. Data is stored in specific region for faster location access. However, this setups may lead to downtime during a region-wide failure. For example, if we are placing some data in localized manner, which is not geographical distributed, like it will at some point, like if the geographical zone get down, the data will until we have to wait until the geographical area get up. You have to wait for them to recover the data. And geo-partitioning leaseholders. Leaseholders can be pinned to specific region to prioritize local reads. While the speeds of read cross region right may become slower, it has duplicates across the geographical areas. Duplicate index. Indexes are replicated across this region for faster read, but comes with higher write amplification. This is ideal for frequently updated data or complication needs. Uh, uh, Transactions. Transaction starts a gateway node that coordinate the process. Changes are professionally until a commit confirms them. Ensure automatically performance ensures automatically. uh, Performance optimization, how the Cockroach DB it optimize the performance is Cockroach DB uses followers read and transaction reflection to handle query more efficiently, especially in geographically distributed setup. Clock synchronization. Uh, Clock synchronization, like CRDB, like Cockroach DB combines physical and logical time to maintain transaction order. This hybrid model avoids dependency on specific like a specialized hardware using standard servers instead. So, with the help of the standard servers, with the help of physical and local time, it maintains the transaction order. A simple timeline with overlapping transactions shows how HSD resolves conflict while preserving monotonicity. SQL layer. Uh, query phrasing and optimization like happens to like optimize the unprocessed SQL queries for efficient execution across nodes. Unlike traditional database, Cockroach DB allows you to update schemas without taking the database offline. User-friendly interface, like it offers a standard SQL interface, makes it easy for developers to adapt, like to work with. Cockroach DB provides like user-friendly interfaces. This TCP benchmark results shows that Cockroach DB demonstrate excellent throughput and scalability in TCP benchmark, which simulates real-world database operations and especially handles high concurrency workloads maintaining performance even as the number of nodes increases impact. By the conclusion, to summarize, Cockroach DB is a scalable fault-tolerant SQL database that provides serialization isolation at scale. It is user-friendly, highly resilient, and optimized for modern global applications. Yeah, thank you.